Hi guys, and welcome back. Today is day 3, and today we will be working on solving exponential equations. But before we get into that, we're going to actually do a little exercise to help us. On our first example here, underneath find a, so expression equals x, I need to find a value that will make my exponent a 1. And when we have a power to a power, we multiply our exponents. So what I need to do is I have 1/2 times k equals 1. My goal is to figure out what a is. I have 1/2 a. In order to get rid of the 1/2, I would simply multiply both sides by 2. Here the 2's cancel out, so I'm left with a equals 2. I'm going to do the same thing here. I have x to the 3/4 raised to the 8 power. Since I have a power to a power, I multiply my exponents. So I have 3/4 a equals 1. In case you didn't pick up on why I want 1, my exponent here is x to the 1st. And in order to get a by itself, I multiply by 4/3, the reciprocal. So therefore I need to multiply the other side by 4/3. Here the 4's cancel and the 3's cancel. So a is equal to 4/3. Same idea. What do I need to multiply -6 by to get a 1? So -6a equals 1. In this case, we'd multiply by a -1/6. As you can see, I'm simply multiplying by the reciprocal. And so I have -1/6. For the last one, what would I multiply -3/5 by to get 1? Well, multiply by the reciprocal, which is -5/3. Everything cancels out over here. So a equals -5/3. That's basically the concept that we're going to be dealing with when we're solving exponential equations when our base is the unknown. So our first step is to isolate the variable. If we don't have x by itself, we have something that's being added or subtracted or multiplied or divided to the x, we need to take care of that first and then get x by itself. The second step is to raise everything to the reciprocal power to get x to the 1st. So that is our goal. Then we will simplify what we have and solve. And finally, our last step is to always check in the original problem. So if I go here, I have x to the 2/3 equals 4. My reciprocal, I have x is by itself, so x is already isolated. My reciprocal power is 3/2. So here, when I multiply my power to power, my exponents simply cancel out, and we're left with x equals, well, we have 4 to the 3/2. Remember, this is power over root, so I'm going to take the square root of 4, which is 2, and then raise it to the 3rd power, so x is equal to 8. And I just need to check. I know it's your favorite thing to do. So I'm going to say to be 2/3 equals 4. So we have our power and our root. Take the cube root first. What's the cube root of 8? Cube root of 8 is 2. And then raise it to the second power. And 2 squared is 4. Therefore it checks. Number 2, again, I have my variable all by itself. Negative 2 is my current power. My reciprocal power is negative 1/2. So I'm going to raise both sides to the negative 1/2 power. Negative 2 times negative 1/2, we cancel each other out. So y equals 9 to the negative 1/2. That's the same thing as saying 1 over 9 to the positive 1/2, because I have a negative exponent. I flip with the inside, so I get 1/9. 1/2 power, so I have to take my root and then raise it to the power. So I'm taking the square root of 9, which is 3, raising it to the first power, which is 1. And then the square root of 1 is 1, raise it to the first power is 1. So I end up with y equals 1/3. Then I need to check that. When I check that, I will have 1/3 to the negative 2 power equals 9. Now, remember, whenever you have a fraction raised to a negative exponent, flip what's inside, make it positive. Your exponent positive. So 9 equals 9. And remember, we talked about before, the fact that I have a negative exponent doesn't change the sign of my answer. It just changes where that number is being raised to the power. Number 3, this one's a little bit different. X is not alone. I have 4x to the 2/3 minus 5 equals 20. Therefore, I need to get x alone. So the first thing I need to do is add 5 to both sides. So I have 4x to the 2/3 equals 25. Next, divide by 4. So we have x to the 2/3 equals 25 over 4. Notice how I did not actually divide that out, because 4 does not go into 25 evenly. Therefore, I want to leave it as a fraction. They're not going to give us numbers that don't work nice. So now, since I have x by itself, I can raise everything to the reciprocal power. My reciprocal power is 3/2. Those cancel each other out. So x equals power over root, and then we take our root first. The square root of 25 is 5. The square root of 4 is 2. So we have 5/2 raised to the third power. So 5 to the third is 125. And 4 or 2 to the third is 8. Favorite thing to do is to check. So we have 4, and then 125 over 8 minus 5 equals 20. Got my power here. 2/3. Order of operations tells me I must take care of this exponent first before I can multiply by 4. So I keep my 4 here. Take my root before I raise to my power. The cube root of 125 is 5. The cube root of 8 is 2. Squared minus 5 equals 20. Square is inside my parentheses, so I still have to follow my order of operations. 4 times 25 over 4 minus 5 equals 20. Now my 4's cancel out, so I have 25 minus 5 equals 20. 25 minus 5 is 20 equals 20. Try that one last time. And it checks. Now number 4, x is all alone, but because I have a radical in the equation, I want to change how it looks. I want to make it into a fractional exponent. So what we were doing yesterday was we were rewriting things. X to the number power, which is cubed, over root, which is squared, equals 64. Since x is alone, we raise to the reciprocal power, which is 2/3. Those will cancel out. And we're left with x equals, well, the cube root of 64 is 4 squared. So 4 squared is 16. So the last thing you need to do with this problem is check it. You can choose to write it as a radical or leave it as a fractional exponent. I think it's easier personally to leave it as a fractional exponent. So I'm going to take 16 raised to the 3/2 power equals 64. Square root of 16 is 4. Now we have to cube it. And 4 cubed is 64. And that checks out. One thing you should realize is they're not going to give you numbers in these problems that aren't going to work. If you are raising something to a fractional exponent and you're taking the root first, you're never going to have to take a root of a number that doesn't work and then raise it to a power. So if something isn't working out correctly, then somewhere you've made a mistake when you're solving. These notes are very short today, only 4 examples, and it's pretty straightforward. Remember, we have a couple steps that we need to look at. Let's go back and review our steps. First thing to do is isolate the variable. Okay, which means get a loan. Raise everything to the reciprocal power, so you have x or whatever your variable is raised to the first power. Then you simplify by dealing with your fractional exponent, and then you solve depending on what your equation looks like. Lastly, you check in the original. And I know that that's your absolute favorite part. Most of the time when you're solving these questions, the problem isn't in the actual math. The problem usually comes up in your, or the solving it comes up in your checks. You're not doing your checks correctly. Be careful of that, and if you need me to show you how to enter things into the calculator, just let me know in class, and I will show you how to put a fractional exponent into the calculator if you are struggling with that. So that was it for today's notes, and we have another day of solving equations tomorrow. It'll be a different type of equation than this. Then we have some application problems, and then we might take a little quiz, do a little review, and have a little test sometime next week. So I hope you're enjoying this method. Things went really long in class today, and I want to thank you for working hard. You guys are doing a great job. So until next time, bye.